As we know, the world is full of diamonds and gems. We are having one of them here today. So I feel honored to introduce our speaker, Dr. Sushil Kumar Chaturvedi sir, Dean Agriculture, Rani Lakshmi Bhai, Central Agriculture University, Jhansi. Sir has did his PhD in genetics and plant breeding from GB Pant University of Agriculture and Technology, Pantnagar. He has distinguished achievement under his head. He has served as Vice Chancellor in the same university, that is Rani Lakshmi Bhai Central Agriculture University. He also served as Assistant Director General in Oilseed and Pulses at ICR New Delhi. He served as Head of Division of Crop Improvement at ICR IIPR Kanpur. He's a great breeder and no doubt has done lot of breeding achievements under his head. He has developed 27 high yielding varieties, out of which 20 varieties were developed of chickpea, which include 15 desi varieties along with 5 Kabuli chana varieties. He has developed Virat variety of mung bean and 6 common variety of different pulses. He has registered 8 varieties of pulses with Protection of Plant Varieties and Farmer Right Act. He has wide publication and has published 386 research papers in journals of national and international repute. He has distinguished awards and recognitions and has served as a member of Research Management Committee at CRP Grain Legume ICRISE. He has been awarded various awards at various stages. He has been awarded with CGIAR Award in 2002, ICRISET Award in 2002, Lifetime Achievement Award in 2014 by Society for Scientific Development in Agriculture Technology at Merit. He is the Executive Board Member in Pradhan Mantri Fasal Bima Yojana by Government of India. He has guided 9 MSc students and has co-headed 12 to 15 PhD students. Sir has vast achievement under crop production and development of different varieties. He has also been the member of AgriMeet Foundation and has given his whole achievements and work toward the AgriMeet Foundation. At the time when we need them for any help, Sir has been there available for helping us in doing and creating new opportunities in the today's era. So I welcome Sir on the behalf of CSGM University and AgriMeet Foundation in collaboration with many other institutes like ICRISAT, IIPR, and many other universities. Sir, I welcome you for the today's lecture.
Thank you, Jyoti. You have really elaborately shared my the CV. Yeah, I don't think that was really required. Anyway, thanks to the organizer, Dr. Sharma, and to you all, and dear students, and the other participants of this particular training program in this evening. So let me go straight with the presentation. Dr. Jyoti, can you start presentation from there itself?
Yes, sir, I will let it start from our side also.
Yeah, okay, good. So just today I'm going to discuss some of the things about the precision agriculture, citing some of the examples from the central India. Of course, as you know, that precision agriculture is a becoming, I should say, attractive word throughout India, and most of the young farmers, students, they are really willing to know that how to go ahead and what really it means. Of course, a lot of literature has been published in past also, and if you see, I think on routine basis now, at least 1 or 2 articles daily you can see in different journals about the precision agriculture. So I think certainly it's an important aspect to deal with, and I congratulate Dr. Ankur Sharma and his team for choosing a right topic for the training program. As I am based in Jhansi, that's in the Bundelkhand region of the UP and MP. So I thought that it will be pertinent to discuss something about Central India. Just take, considering it as an example, certainly precision agriculture can be started anywhere in all the type of soil, climate that's there. But I thought that let us take the example where really you can visualize what type of things can happen and what we can do. So by the title goes, as you have already seen, the precision agriculture in context of Central India. Next one. Yeah, so it's right to share some of the things. So I thought that I shall be talking about little bit about the Central India, then something about the philosophy behind the precision agriculture, then some principles, then conventional versus precision agriculture also. And so just a few points I shall be covering. And the important thing that at any point of time, anyone is willing to ask something, see or he can ask also, or if you can just record those your questions or the query at the end during interaction, I can respond to various your queries or the questions. Next one. So as you all know that Central India has typical soils, undulating topography. So different type of soils are prevailing in India, and so as with the Central India. But in Central India, typically the four types of soils are prevailing. If you see the Uttar Pradesh, Madhya Pradesh, part of Maharashtra, and Chhattisgarh. Of course, little bit of western, southwest Rajasthan as well. So if you see this in Central India, then deep black cotton soils are there. Those remains to confined to some area, but these soils are rich in organic matter. That's what we say, that black, deep, and cotton soil. Then different types of second type of soil, particularly in Bundelkhand region, we see the where clay is also there, but deficient in the organic matter. You can see the color will remain black. So sometimes people get confused that whether this type of soil is maar or kavar. In maar, a lot of organic matter and clay content is there, but in kavar, it's just a fragile soil. If you take on hands, then certainly if you rub it, then you can feel it's really fragile because the clay content is less. Then we have red soil in Central India. Those have the gravels, slightly acidic soils are there, but certainly these soils are also shallow. Then we have whitish soil, wheatish color, some light color soil. Those are the alluvial soil, slightly alkaline and have deep. So certainly soil depth is good, but these have the problem these soils are calcareous soil. So different type of soils are there. Next one. Then as we know that the major constraints in the Central India, because most of the part of Central India is in plateau region, so all the characteristics of the plateau region are dominating at farmers field as well. So is with the Bundelkhand tract of the Central India, about which I am going to talk. So undulating land, because it's the plateau region, so most of the soils are land is the undulating. Hard rock seeds are underneath. That's what the soil depth varies from one place to another place. So those become the soil shallow. Then the soils are mostly deficient in nitrogen, phosphorus, sulfur. And once these soils are deficient in these nutrients, so certainly the yields levels are very poor. Then even when we have the good rains, we are not able to get the attain the very good yields in these soils. Then the crusting problem in light alluvial soil, in mixed red soil and black soil because it's small, clay content is less. So crusting is again a major problem. Then the drainage in black soil, that's often during Kharif season, that hampers the proper growth of the crop, and waterlogging leads to damage to the crop in some of the pockets where drainage is an issue. Then inadequate rain water harvesting structure or the practices. Earlier in ancient times, these were there, but now slowly, water harvesting practices uh, have come to almost minimized. In most of the areas, it's now almost zero. So again, government has taken good care, central government and the state governments, they have taken care. And again, rainwater harvesting structures are being created and government is providing sufficient funds for that. Then long back, soil conservation was given due emphasis. One in recent year, little investment is there in soil conservation practices in central India. Then runoff, since the slopy lands are there, so runoff is also very speedy. So once the runoff is there, that takes away the fertile soil, and a lot of soil erosion can be seen in entire central India. And then again, the low level of farm mechanization is there that leads to the higher cost of cultivation. Of course, in some part of the central India, like in Maharashtra, some part of the Madhya Pradesh, like in Malwa region, where farm mechanization is optimum, I should say. But in other parts of the country, central India, like the Bundelkhand tract, is still farm mechanization state is really very poor. No level of mechanization is there. Of course, many farmers have purchased big tractors, but we don't have other farm machineries with them as well. Then the transfer of technology network is again very poor in central India, varying in some states, and because the harsh environmental conditions prevails in central India, so many people, those are responsible for the development in this part of country, they don't take much interest. That's what the transfer of technology network has become very poor. Then the stray cattle problem is also prevailing in entire central India, I should say. So certainly these are some of the characteristics, and if we can take issue, these characteristics like an issue, then for each issue we can certainly provide some of the solutions through precision agriculture. Yeah, next one. So just let us, what I thought that let's understand what's really precision and smart means. If you can make the balance between two sides, certainly that's sometimes people say it's precision. Means precision when everything is good. If you can see this half circle, it's beautiful. Two beautiful pathways are there, one circle is there. That says that precision, everything is precisely done. But if you say what has been done smartly, then in the front part where you can see some of the tents, you can see these have been done smartly. Fields, you can see that ground is not proper. It has different type of dimensions, but each side of the field has been used properly. So that's the smartly. Means the available space has been utilized smartly to erect the tentage, to have some function. So that's the difference between the precision and the smart. Precision means you have to be perfect in each aspect. That's what the bottom one half circle and the straight path and the round that says. So there's similar differences are there in agriculture, conventional agriculture, and now what we are talking about the precision agriculture. Next one. I don't see that these definitions are to be repeated, but certainly what really it means. Sometimes we say precision farming, sometimes we say precision agriculture. So what's really that? It's in simple terms. If you say that using the advanced technology to maximize, of course, in literature, you will find the optimized crop yield or the crop production. But what we feel that precision agriculture leads to of maximum yield. So if you are resorting to precision agriculture, then our target should not be to optimize crop production, but certainly to attain higher yield. When I say higher yield, means yield maximization can be attained through precision farming. That should be the target. So what it really required? It requires amalgamation of the different technology or the integration of the different tools and techniques available. After the advent of the information technology, now many things are being integrated in routine.
हेलो हेलो सर, सॉरी टू इंटरप्ट यू बट शायद आपका माइक म्यूट हो गया.
Now it's fine.
यस सर.
Yes, sir. अब आप audible हैं, sir.
Okay, maybe some problem. Just I was talking about the precision agriculture. What we really, or we say sometimes we said precision farming. So if you see in literature, commonly we are using both the terms, and the main philosophy behind the precision farming or precision agriculture is to utilize the information technology and the other related technologies available as on today. After advent of the information technology, now it has become really very easy to transfer the messages to the clientele. Then certainly if we are at right time, we are providing the advice to the farmers or the client, then certainly their agriculture will become a profitable one. Next one. So while using the technology, what we do, we use this technology and we generate data, we analyze data for crop wise or for the area specific data. Once that data is available, you can analyze, you can integrate, and precisely you can advise the clients. Even you can manage your own using the information technology, you can easily manage your own farm. And we have suggested to establish at least modules in some of the universities. In last meeting, I was in Delhi, I suggested that at least some of the working modules should be established in some of the universities so that the students and the other stakeholders can really visit and learn those precision agriculture modules. So rightly said that precision agriculture involves the satellites, drones, and other technology that is required to manage the crop yields. When from where crop yield can be improved, certainly if good soil is there, you can manage the soil, you can manage the nutrients, you can manage the requirement of water. Then certainly if we can manage these three, we say that the Chit-Jal power, if we can manage, then certainly the crop health can be ensured. Once the crop health is good, then certainly that will provide good productivity. So that's the precision agriculture. Means precisely using the scarce farm resources. If we can ensure by using different tools, then that's the precision agriculture. It's not only the laser labeling. Somehow in minds of the many farmers and the students, it has gone that precision agriculture means the zero leveling. If we are using laser leveler, we are maintaining our fields at zero level with gentle slope, then we say it's precision agriculture. It's not so. Precision agriculture that's only one component of the precision agriculture to go with the laser leveling. Otherwise, there are many aspects of the precision agriculture. So precision agriculture can be, it's a really a management system that takes the care of the spatial or temporal variability within the crop or the soil factors. Then it becomes the precision agriculture. So the system, what's that precision agriculture? The precision agriculture system aims to attain real-time robust mapping system for the crops, soil, and environmental variations. When we do the environmental variables, then certainly on all the nutrient dynamics that comes into the picture, and that really helps in improving the crop yield in a particular field. So what traditional agriculture we were doing, it's not that we were not precise in agriculture. Previously, in early times also, we were very much precise in crop production. But what was lacking, that we were considering that the fields are, crop fields are mostly the homogeneous, or that not that was not the right issue. So what we were saying, that once we have gone for a leveling of field, we thought that okay, the soil depth will be uniform, but it's not so. When we thought, okay, let us apply the pesticides or the foliar application of nutrients for that matter, or for better crop management or health management, what we were doing, we were just taking the observation phenotypically, and we were applying the required agrochemical. But now precisely under precision agriculture, what we have to do, precisely wherever it is required, we have to apply. It means we are going to save the cost of the agrochemicals and also the labor cost of the cost energy that is required to run a particular machine. Next one. And then what's the requirement? We all know. So that's not a really big thing, that soil sensors are required. Why soil sensors are required? So just one why, when I will try to explain why these things are required. Let's say the soil sensor. These are the requirements. So why? Because crop has to be grown on soil. It means you have to monitor soil. So how soil moisture, soil nutrient status can be maintained, monitored? Certainly we need some soil sensor or a technique or any technique that can provide the required information from the or for the particular field or a particular soil. That's what these soil sensors are required, and these sensors can be linked using the information technology tools. Then the crop sensors are required. What for? Again, to monitor the stress, maybe the plant density, maybe the light capture, solar light capture efficiency, utilization efficiency, and all parameters related to growth. Let it be the phenology, days to emergence, after emergence, accumulation of biomass, reaching to the reproductive stage, then reaching to the senescence, harvesting. Also, these sensors can serve the purpose of the plant count, starting from the emergence to plant count to harvesting and and the expected yield. Even these sensors on plant basis can suggest, okay, a particular plant is going to, how much a particular plant is going to produce the grain yield or the seed yield. Precisely that can be monitored using the crop sensor. So what crop sensor we can do? Other things crop sensor can do, they can monitor. Using the crop sensor, we can monitor the nutrient deficiency. We can monitor the incidence of disease or progression of the disease, or the damage being caused by the insects, or the moisture stress. So all kind of parameters can be studied using the crop sensors if we are willing to monitor the crop. Then the automatic farm machinery, even for harvesting, for right from the seeding to harvesting, farm machinery is to be used. So certainly the automation of farm machinery is required. Precisely how much deep tractor has to plow or a cultivator has to dig the soil, that precisely we can maintain. How much, at what distance seeding has to be done, at what time harvesters are to be used, which harvester is to be used to minimize the grain damage, same with the to recover the straw. So what type of harvesters are required, at what time those harvesters need to be employed in a particular field, same way the seeder, which type of seeder is to be used at a, like the a particular distance, seed has to be to fall, or the seedling has to be planted. All these things can be integrated in precision agriculture if we have the particular machinery. Since the labor cost is increasing day by day, so certainly automatic farm machinery can help to make the agriculture a profitable business again. Otherwise, due to increasing cost of the manual labor and the rent of a particular machinery, if someone or the cost of the machinery, it is really becoming difficult to make profit out of agriculture, particularly for the small or for the marginal farmers. Big farmers, they have the money, they can afford the machinery, so certainly they can make good profit. But for small and marginal farmers, we need to establish the custom hiring centers for automatic farm machinery. That only then precision agriculture can become successful in this country. Next one. Then certainly, like there are many aspects in biotechnology. Also, what we have to do, we have to go for the phenotyping. We have to identify a gene. We have to develop the go for the gene editing. So all for sort of businesses, certainly the precision that also comes under the precision agriculture. We can create new pest and diseases control methods, or for the monitoring of a particular diseases, these sensors can be employed, and the information generated or gathered through these sensors can be utilized for the setting the priorities in biotechnology as well. Then the hydroponics, that you all know, that soil-less method for growing the plants is the hydroponics, where we use the nutrient-rich water. So what we can do, we can really precisely, using the sensors, we can precisely supply the nutrients whenever required. Whenever it is required to change the water, sensors can monitor the water quality and the nutrient solution. Then, as per need, we can apply, or we can use those nutrients to grow the for the properly growing the plants under hydroponic condition. Of course, I have not mentioned the aeroponics, but aeroponics also, their automation can be done. And once that automation is done, then certainly the cost of cultivation under hydroponics or aeroponics condition, under both conditions, can be minimized. Then the smart irrigation system, like the Ferti irrigation system, everybody is talking about now the micro irrigation system, let it be the sprinkler, let it be the drip method, both our artificial intelligence and the sensor-based technology we can integrate. Then certainly we can control the plots of the irrigation system using the palm top or the mobile. If we can configure on our mobile, when we can get information from the field that, okay, this particular part of the field is facing stress for water, then certainly right from the using the your mobile and the software, what we can immediately instruct the sprayer. Okay, for this particular place, you need to spray the nutrients, or there is need to spray the water so that sufficient moisture is there. So whether it's a sprinkler or the your drip irrigation system or the other system, all those can be maintained using the sensor-based or the IT technology, and that's what we say. These all are the part of the precision agriculture. Next one. Then already I have said that automation of the equipment, that is also must to reduce the cost. And now a number of machineries and even the tractors, planters, all are coming with the guidance system. You can mount a system at how much distance seed has to fall, at how much distance should be between rows, how much distance should be from the edges. All those sort of things can be done. We can optimize planting, seeding, all sort of business can be done using the automated equipments now. Then the smart or the advanced analytical tools are also becoming available day by day. And using those smart, advanced analytical tools, we can precisely pinpoint even the small patches where the nutrient deficiency or moisture deficiency is there, or if there is any outbreak or the initial symptom of a particular disease of a particular crop. If we can load that information, then certainly the system will take care of and can suggest which disease is going to appear at what time if we are monitoring the soil, moisture, soil and moisture and the weather parameters. Then certainly those analytical tools can help in precisely guiding the crop management practices. Then the blockchain is again blockchain technology, or that also that is also the part of the precision agriculture to increase the traceability system and to have the transparency. A lot of people, many people are talking about now the traceability system in seed, because nobody knows from where seed is coming. So if we can just a single intervention of the traceability system in seed can entirely change the scenario of Indian agriculture. Why I say? Because even the farmer or the clients, they can show them, okay, look from where the seed was really produced, whether the seed has the certification, whether the certification agency has really monitored it, whether the seed has come from the right source, a right kind of variety, what it being named. If let's say a name of variety is, let's say something, it can be the Pusa 256 variety. But using the traceability system, we can monitor whether this variety has been really multiplied at right location, whether the supervisor was the breeder or under the guidance of a particular trained person, it has been produced, whether it has been certified, if it has been certified, from where it has been transported to which place, whether from the transportation place there was the mixture, how much it was transported. So all those small bits or tidbits can be uploaded on that traceability system. And once that traceability system is at place, certainly the quality of the agri input can be ensured. Again, to the consumers also, once the farm produce is available, let's say everybody is now talking about the organic farming or the natural farming. So how to really retain the information or the share information about the food being produced through organically or through chemical farming. For that, this traceability system can really help to clients also. If let's say if seed is that some farm produce, or the vegetables or the fruits are being produced by someone under natural farming condition or under organic farming condition, right from the production side to the up till it reaches to the consumer, all that information can be loaded. And if someone is interested from it has been produced, then certainly that QR code or the barcode, those can be scanned and all information can be gathered from where it has really this particular producer has come. So to ensure the quality, these technologies can also be used, and certainly if we are using that, then it will give the confidence to the client, and certainly the farmers or the consumers both will be at the benefit stage. Next one. Then again, talking about the several technologies, I'm not going to share about the details, but certainly you all know that global GPS technology, that's one, so that precisely you can map your field and where it can be used. Really, the GPS is required to locate the field, to map the field. Once the information about the field is precisely being maintained through or being communicated through the media, that can be saved. And for any crop, for that matter, if being grown in that field, then the right kind of advice to grow the crop can be provided through the system if we have that automation. So is with the remote sensing, because the data has to be, it's very good for the monitoring of the crop growth, for the diseases, nutrient deficiency, pest infestation, for all those sort of stresses, remote sensing can help. And that's what the sensors are being mounted on on the agricultural portals, and we as on agricultural satellites that we are doing. Then the what else we can do using the remote sensing? Remote sensing can also help in estimating the losses. Let's say there is in some of the pockets due to hails or due to flood, crop damage is there. Immediately we can monitor the crop damage in that particular field, and precisely we can say that how much damage has taken place to a particular crop in a particular field. And that can be linked with the Fasal Bima Yojana, that's the crop insurance scheme. And if we can link the data being collected through this remote sensing on crop losses, and it can, if that data can be linked with the Fasal Bima Yojana, or let's say the farm insurance policy or the system, then certainly farmers can be provided the compensation by the insurance agency. So certainly these technologies can be used once the farmers are assured that they are going to get the right price for the produce, or if there is any loss after the crop insurance, then certainly they are going to get the compensation from the insuring agency. Then farmers certainly they can take risk, and they will use all kind of they will start using all kind of technology. Then recently in last 1 year, we all know that everybody has started talking about the drones. What drones can do? If we can mount the required equipment on drone, like the cameras and the sensors, and part of the sensor can be placed in the crop field or in a area, then certainly all kind of surveys can be conducted using drone. Like where we can't go for, let's say the example of attack of locust. If some insect pests like locust are there, it's very difficult to control, but using the drone at in the trees, if they are there, hibernating, if they are on the trees, certainly the drone can help in minimizing the loss, and immediately those drones can be deployed to manage the locust population. So that's not just one example. Otherwise, the lot of images, high resolution images can be captured using drone. And once those are analyzed, certainly with effectively and with efficiency, we can say whether this particular crop has a problem of disease, insect pest, or the nutrient deficiency, or the soil moisture deficiency, or due to other problem. So all the crop progression can be monitored using drone, right from seeding to harvesting. And otherwise, these drones was usually these were invented just to monitor the infiltration from the border areas. Then the already I have shared something about the soil sensor. Using the soil sensor, soil moisture, temperature, pH level, nutrient availability, all those sort of things can be managed. We can collect the information on these different aspects using the specific tools and techniques. Then certainly these can be integrated, and once those integrated, automatically the we can extend the package of practices, and using those package of practices, we can issue the advisories to individual farmers of the region or of the state or of this country. And if we can do that, then all farmers will get, most of these farmers will get benefit, and certainly we can increase the efficiency of the agri production. If we can do that, then certainly the required quantity of food and the vegetables, all sort of things, country has capacity to produce. That's what the precision agriculture is now being talked about. Next one. Then just to quote example, because in crops, mostly we discuss about the plant phenotyping. So the plant phenotyping is also the part of the precision agriculture. That's what I am going to discuss about the laser labeling here. So, or the use of the sensor technology in managing the water or the irrigation. But certainly I'm going to quote the example of the plant phenotyping, particularly of the diseases, insect pests, how really precision agriculture or these tools of the precision agriculture can help. The sensor-based technology, now that's available. The number of sensors are available specific to the particular stress for the detection and identification and quantification of the plant diseases. But I'm just going to share some of the things about the plant diseases. So these sensors access the optical properties, because these sensors have that property. So electromagnetic spectrum can be generated, and that information can be utilized where we can't say for that particular area. Once you utilize that, then that information can be analyzed critically, and based on that analysis and the pre-loaded information in form of the images or in form of the text or the figures and chart, certainly that can be collaborated. Once that is collaborated, then the right kind of advice or the advisories can be issued. That's what the Ricard brother said, that we need better methods of diagnosis in plant to manage the plant diseases. What we need better methods of diagnosis. None of the methods given are to be considered as standardized. Means whatever we are doing today, we have many phenotyping technologies or the techniques. I'm not saying those are not good. They are also excellent. They are also good, but always there is chance to develop better ones. That's what the for the phenotyping, precision agriculture or the sensor-based technology can be used to think of them. Ricard has rightly said that to think of them in such a way would put an end to the efforts of improvement. But if we are complacent that, okay, we have the standard techniques already available, why to go for other techniques? It means we are going to end to the efforts of the improvement. It means the science has to continue and we have to embrace newer technology for the disease diagnostics. They are useful only until better procedures can be developed. He added, he said that good, if you have the better good technologies, but again, there is always a scope for the further improvement. That's what he said. They are useful only until better procedure can be developed. If you can develop better phenotyping technology or better technology for the diagnosis of a particular disease or a stress, nothing is better than. And so there is always scope for the improvement. Next one. That's what the what sensor can do in pathology. So these smart sensors can detect early changes in the crop physiology once the plant physiology is assessed due to biotic or abiotic, due to biotic stresses. In this particular case, I am talking about the diseases. So these diseases can cause modifications in tissue color, leaf shape, transpiration rate, canopy morphology, plant density, besides variation due to solar radiation interaction with the plant interaction. So solar radiation, plant interaction, those interactions are also going to affect the disease development. So these sensors can certainly monitor these. And what earlier we were doing? Earlier we were usually monitoring, what we were monitoring? We were monitoring the modifications in the color, not the tissue culture, in the morphology. It means our identification for the diseases under field condition was mainly depending on the eyeball judgment or based on the phenotype. But using the recent technology, what we can do, we can see the change right in the tissue. If tissue has started discoloration or color is changing of the tissue, certainly with that only we can guess which disease is going to come. So if we know the disease at the early stage, we can diagnose that certainly the damage is likely to be caused due to the particular disease can be minimized if we are using the right kind of technology. That's the sensor-based technology that is now available. What it does, sensors provide the information and already available information through images and in the text form that can be utilized to identify or diagnose a particular disease and to suggest the remedies or to control measures for a particular disease. Currently, the most promising techniques, as I said, that sensors that measure the reflectant, temperature, or fluorescence are now becoming available. So the old sensors or the old technology will get we can get rid of, and certainly in time to come that will become obsolete, and newer technology based on the fluorescence is coming up. Next one. So the identification of the diseases based on the spectral properties, what I said, other than the images, if you go, there's certainly what I have tried to pinpoint here, that using the technology, one can pinpoint a crop, one can pinpoint a particular disease. That's what this particular experiment has shown, that healthy one, you can see the peak, or using the wavelength that solar light reflectance has been monitored. So using that particular sunlight, it's given underneath. You can see the wavelength is given for the rays. So you can see the healthy plant. Then net loss, that's a particular disease. Second, other disease is rust. Third one is powdery mildew. If you see the peaks for these three, then you can certainly with certainty you can say that okay, matches with the, let's say, if your picture is matching with the hyper spectrum and matching with the third one. Third one means the rust. With the rust, it means a rust is coming up. One can immediately guess, okay, these are the initial symptom of the rust. So to manage the rust disease, we have the fungicides. Those fungicides are to be applied immediately. So that's what the this technology can differentiate between the diseases. And once that it can be, disease can be identified, certainly for a particular disease, recommended fungicides can be recommended. That's what we are, in addition to disease, now many scientists have started advocating about the management of the weeds also. Let's say if there is a crop of wheat, then what technology has to do? This technology has to do, this technology has to identify the wheat crop only. And if using the sensor-based technology or the image-based technology or the hyperspectral-based technology, with the integration of these, if we can identify, okay, this particular crop is wheat, other than wheat, wherever the other plants are there, they need to be sprayed with the using a recommended fungicide, then certainly that weedicide, then that information can be uploaded, and wherever the weed infestation is there in a particular wheat crop, certainly we can manage with the this technology. It precisely will say where we need to spray weedicide. Once that is known, there's certainly cost of the herbicide that will also get reduced, because you need not to, farmer may not be required to spray a particular weedicide in the entire field. Farmers can go in a particular place, in a particular area, and only in that particular patch he needs to spray the herbicide, considering that maybe the weeds are in other part of the field also, but those weeds are not going to cause the economic damage. Once that economic damage is less in comparison to the cost, then certainly there is no need to spray. Such type of advices can be issued to the farmers. Next one. Next one. Yeah. So that's what the I am trying to highlight the precision agriculture versus the plant phenotyping. So far, because now we know that phenotyping can be done, then the precision agriculture. So where really we match. So precision agriculture, what is required here is information technology, those the optical sensor, GIS, GPS, then the crop parameters, soil parameters, environmental parameters. These are the some of the things required. That's the basic data. So basic data set has to be generated, and then the what is to be done? Then the decision support system, using the expert system, we can identify which is the one is the particular disease. If we can identify a particular disease, immediately we can suggest the management practices. So that's what we did say the precision agriculture. Same way, like we said in precision agriculture, for phenotyping also, that precision has to be there. So what can be done? Let's say we have the 10,000 germplasm lines or the genotypes are available. Then we have to, what we have to do? we have to go for the genetic trait of selection. So how to identify? Here again, the precision is required because we are not going to select all the genotypes. From this set of the genotypes, we have to select a genotype that has a targeted trait. It means precise phenotyping is required. Once the precise phenotyping is required, what it really means? Quantity and quality both have to be taken care of. That's what the out of 10,000 we may select hardly 1% or 1%, or that's the 10%. Here they have selected. We can reduce the selection. We can put the selection pressure. We can reduce the number of selections precisely. We can go for the phenotyping, and based on genotyping, wherever the genes are there, those genotypes can be selected, and then the phenotyping we can do the phenotyping for the selected genotype. Out of those, again, we can retain the genotype where the phenotyping data is matching with the genotyping data to reduce the load. And at the end, what we will get? We will get minimum number of the genotypes. And these genotypes are to be used further for the development of the varieties. That's why the precision agriculture or the plant phenotyping in both similar type of precision is it. It's not that precision agriculture is only that, earlier I said, management of irrigation, management of the soil topology. It's not. Right from the preparation of field to the harvesting, to the threshing, precision agriculture, these tools can be deployed. Same way in the developing the varieties. At each stage, potential is there to use these technologies. It means it's not one aspect. Precision agriculture, if you are talking in a holistic manner, then right from the developing a variety to the management practices to the protection practices, all comes under precision agriculture. Next one. Yeah. Then just to add again to the same, that here what we have done, we have just suggested that several technologies are now available. And these technologies like RGB, multispectral technology, hyperspectral, thermal, chlorophyll-fluorescence, or the 3D sensor-based technology, all these technologies available, they are being used now. Once the system is perfect, we can certainly start using these technologies in real world conditions as well. Of course, many technologies are being used in developed countries, but days are not far away when India will also start using routinely some of these technologies for the optimizing yield of the agricultural crops, vegetables, or the other horticultural crops. Next one. So these are some of the examples. Number of examples are now available. So these are some of the examples where these 4 or 5 technologies have been used for the disease diagnostic purpose. Like RGB technology has been used for the color technology has been used for the cotton. Certainly the images can be collected and those images can be analyzed for whether the disease is bacterial angular disease or the ascovite blight is there. So for diseases in case of cotton, the technology has been utilized. Same way the spectral test sensors have been deployed in case of the barley and wheat to monitor the disease progression or the disease occurrence, like the net blotch, brown rust and powdery mildew in case of barley, head blight and yellow rust in case of wheat, orange rust in case of sugarcane. In these diseases and the crop, spectral sensors have been used. Thermal sensors have also been used, particularly in the sugar beet, where the Cercospora leaf spot diagnosis was done and the management practices or the advisories were prepared and issued for managing the this Cercospora leaf spot disease in case of sugar beet. Same way in process imaging, that this technology is being used in case of wheat, sugar beet, bean. A number of crops are there. Deliberately, I have not placed the put up here all the technology crops, but some of the technology, just for the sake of the examples I have cited here, like in case of wheat, leaf rust, powdery mildew, these are the important ones. So process imaging has been utilized. In sugar beet, again, for the Cercospora leaf spot. In bean, common bacterial blight disease, process imaging has been used. These all technologies I will say the imaging technology or the thermal sensors or the fluorescence imaging. These can be used to monitor disease development, and these can also be used for pinpointing the nutrient deficiency in developing plants. It's not that only in samples we can do. Crop progression can also be monitored using these all technologies. And underneath, I have mentioned the software that is available on website. Anyone can download and you can see how this plant image analysis can be done. And number of softwares are now available on this particular repository, in this repository. Next one. Then what we were doing, just to apply those, we were using the conventional method where we were protecting the field, and once those fields were protected, we were recording the observations. Now these observations are to be meshed with the images. So what you have to do? One has to collect the information using the conventional method, then using the different imaginaries or from the these sensor-based technology. Then revalidation of the after integration is required. Once the procedure is good, then that particular technology or tool can be used or can be deployed in real world situation. Once these tools and techniques will be utilized by the individual farmers, certainly the production and productivity of the targeted crops will be much more whatever we are harvesting today. Next one. Then there are many challenges, like in India, what challenges we are facing? We have a large number of farmers are smallholders. We don't have many big farms. So that's a major issue in popularizing the precision agriculture, because the smallholders, they don't have money to invest. So, and they don't have access to the technology, we can say. So that's the major issue. Then the trained manpower is again issue. So we have to train manpower. Then the poor economic background of small and marginal farmers, that also restricts them to access the technology. So for that, the policy change has to be required, and government is fully aware of its own responsibilities, and government is providing subsidies and the credits for the purchase of the farm machinery or all these technologies to the farmers, and those who are willing to establish custom hiring centers in this country, at least in, I will say in many states, I should say, the subsidy component is available, and individual farmers or the group of farmers or FPOs or self-help group, they can certainly purchase those equipments availing the crop subsidies, the subsidies on farm machinery, and also credit from the bank. So challenges are there, but there are ways and means to manage with these challenges and to improve upon. Next one. Then, as I earlier said, that capacity building is required. So certainly the interdisciplinary team has to be there for the capacity building. Then the pathologists and crop physiologists must come together to understand interaction between biotic and abiotic stresses. It means these two groups should work or must work together to understand the problem in better way. Then similarly, the microbiologists, soil scientists, agronomists, they should also work as a team. Breeders should also have at least physiologists and crop physiologists in team, because then the crop physiologist can be the member of the team, as I suggested, with the pathology or with the other groups. So a multidisciplinary team has to be there for capacity building of the farmers, for the trainers. Until that is there, then certainly we can't progress. So government is also fully aware about these issues, and government is issuing many circulars, I should say, for capacity building. It is being promoted by DST, by DBT, by Ministry of Science and Technology, by Information Technology Ministry. So number of ministries are now promoting the multidisciplinary approach, and for the sensor-based technology utilization in agriculture. And just I have mentioned one reference, those who have interest in more in precision agriculture for managing the plant diseases or for the plant diagnostic or for the development of the high yielding varieties having the resistance, they can go through this particular paper. It's excellent paper. That's why I have mentioned only this particular paper. If those who have interest, they can read it. Next. Then just to summarize, as we said that manpower cost is increasing day by day. Therefore, it is inevitable to use advanced technologies to optimize crop production, minimize input use, and increase profitability. So if precisely we can use the agri inputs, certainly cost of cultivation can be reduced. Once cost of cultivation is reduced, yields are more, then the profitability will also increase. Similarly, in breeding programs targeting development of multi-adversities resistant varieties or tolerant varieties of crop must start using images-based phenotyping techniques for scoring against particular stress, to have more precision in selection, and sensor-based tools to monitor stress levels, particularly against abiotic stresses. If we can do that, and these can be these can routinely be deployed in large breeding programs, certainly the efficiency of breeding program will also increase. Then the close monitoring and analysis of the data, precision farming can be used to make decisions within a short period about the crop management, leading to healthier crops, increased profitability, increased productivity, and to have more sustainable approach to farmers. With this, thank you. Thank you. Next one. Thank you. Thank you. Thanks to all.
Jyoti.
So if there is any query, any clarification regarding precision agriculture in general, those who have interest, they can ask, or those who have queries or the questions, they can certainly pose, and I will try to answer some of those.
यदि किसी को कोई डाउट है तो सर अभी बैठे हुए हैं, आप पूछ सकते हैं.
बिल्कुल, किसी तरह का कोई डाउट है, आप बिल्कुल हिंदी में पूछिए, अपनी भाषा में पूछिए, ठीक है, जो आपकी बोलचाल की भाषा है उसमें पूछिए.
पहला डाउट आया है सर, प्लीज शेयर पीपीटी.
Sure. So these PPT, yeah, certainly there is no harm. These PPT can be shared with the attendees. No worry. Okay, nothing is like IPR. So all this
Sir, how can this technology help in fruit science?
How this technology can use in fruit science? Let's say so while let's say for the management of the insect pests or the diseases, that's number one, because it is being used in most of the developed countries for the management of the diseases and insect pests. That's number one. Okay. Using drone technology, we can drone can be used for the purpose of applying the required herbicide, required fungicides, or the required your insecticide. But the other aspect that we are often ignoring, that these sensor-based technology can be used for the purpose of harvesting the fruits, because the harvesting of fruits becomes very difficult because of the non-synchrony. Synchrony in maturity of the fruits is not there in most of the cases. So how to pluck the right kind of the fruits or the matured fruits, certainly this technology can help. Then how to pluck diseased fruits or the damaged fruits, this technology can again be deployed. And if we can do that, certainly the quality fruits from in shape, size, color, those can be picked up from a particular tree. So certainly a lot of scope is there for deployment of the sensor-based technology to the fruit crops as well.
So the next question by
ज्यादातर लोगों ने यही लिखा है सर, नाइस प्रेजेंटेशन, नाइस पीपीटी, नाइस प्रेजेंटेशन। पीपीटी दी जाएगी कि नहीं, यही लोग
बिल्कुल दी
ज्यादा
जाएगी, पीपीटी बिल्कुल दी जाएगी। और ये टेक्नोलॉजी ऐसी है कि आज के 10 साल बाद, आज तो इस देखिए कब जब कोई चीज नई स्टार्ट होती है तो तमाम हेजिटेशंस होते हैं, ठीक है। ये टेक्नोलॉजी ऐसी है कि इसके यूज में हेजिटेशन कंट्री में लोगों को इसलिए नहीं होना है कि जितने लोग यहाँ बैठे हैं, जितने भी लोग इस ट्रेनिंग को अटेंड कर रहे हैं, सभी के पास मिनिमम मोबाइल है। जब एंड्रॉयड मोबाइल्स है, एंड्रॉयड मोबाइल से हम मैसेज भेजते हैं, वो मैसेज हम पढ़ते हैं, वो चाहे ऑडियो मैसेज हो चाहे वीडियो मैसेज हो। इसका मतलब है कि ये टेक्नोलॉजी यूज करके हम अपने फार्मर्स को, अपने क्लाइंट्स को, अपने कंज्यूमर्स को, व्हेन आई से क्लाइंट्स मींस फार्मर्स एंड कंज्यूमर्स बोथ, इन सभी को हम एडवाइजरी जारी कर सकते हैं जो उनके लिए रिक्वायर्ड है। लेट्स से किसी इंडस्ट्री ने एक क्वेश्चन किया कि हमें यूनिफॉर्म टाइप का ग्रेप्स चाहिए, ये साइज है, इस सीजन में चाहिए, इस मंथ में चाहिए। आपके पास इंफॉर्मेशन है वो ग्रेप्स का कहाँ प्रोडक्शन हो रहा है, कौन सा साइट है, वेदर these grapes are being produced organically or which chemical has been used. Immediately that information can be uploaded, and certainly using the barcode. I said that traceability system, if that is on place, the produce from a particular field can be monitored whether this particular consignment is coming from that field only or someone has mixed some of the fruits on the way. So that's what traceability system is becoming important. तो ये जो टेक्नोलॉजी है इसका यूज डेली लाइफ में है, मैं एग्रीकल्चर की बात नहीं कर रहा हूँ, इस टेक्नोलॉजी का यूज डेली लाइफ में है। आपके जो सेंसर का यूज हो रहा है ब्रेकिंग सिस्टम में, आप गाड़ी लेके जाते हैं, स्कूटर चलाते हैं, उसमें भी सेंसर है। आप टर्न करते हैं, सामने से कोई ऑब्जेक्ट आ रहा है जिससे आपको हार्म हो सकता है, अगर सेंसर है तो आपको वो बीप देता है। बीप का मतलब हुआ कि वो आपको एडवाइस करता है। अगर आप रोड पर ट्रेवल कर रहे हैं, रोड में सेंसर लगे हुए हैं, आपकी गाड़ी में भी सेंसर है, जब आप सेंसर के ऊपर से निकलते हैं तो आपको आपकी गाड़ी में बीप सुनाई देता है। वो क्या बताती है कि आप ओवर स्पीड है। आपका जो सेंसर्स हैं आपकी स्किन पे फिट कर दिए गए हैं। जब वो सेंसर आपकी स्किन पे फिट है, आप गाड़ी ड्राइव करते हैं, आपको नींद आती है। जैसे ही आपको नींद आएगी, सेंसर आपको कहता है, रोड पे भी सेंसर है कि गाड़ी आपकी बहक रही है, कहते हैं। जैसे ही गाड़ी बहकेगी वो सेंसर आपको सेंस करके बताएगा, बीप देगा कि आप गाड़ी ड्राइव कर रहे हैं लेकिन आपको बीच में नींद आ रही है। तो ये जो सेंसर बेस्ड टेक्नोलॉजी है इसका यूज डेली लाइफ में भी होने जा रहा है। इसलिए अच्छा है जो ट्रेनिंग है, मैं बधाई देता हूँ डॉक्टर अंकुर शर्मा को और उनकी पूरी टीम को कि जो टॉपिक है ये केवल प्रिसीजन एग्रीकल्चर तक ही सीमित नहीं है। इसके जो टेक्नोलॉजी के बारे में जो तमाम अभी जो और स्पीकर्स होंगे जो ज़्यादा एग्रीकल्चर में इस बारे में जान रहे हैं, जो इलेक्ट्रॉनिक्स के बारे में जानते हैं, सेंसर बेस्ड टेक्नोलॉजी के बारे में जानते हैं, हाइपर स्पेक्ट्रल टेक्नोलॉजी के बारे में जानते हैं, इमेज एनालिसिस की बात करते हैं, जब वो इसके बारे में और डीप में आपसे बात करेंगे तो आपको लगेगा कि ये जो टेक्नोलॉजी है ये केवल एग्रीकल्चर के लिए प्रिसीजन की बात नहीं कर रही। जहाँ भी हम प्रिसाइज बात करेंगे ये प्रिसीजन के लिए ये टेक्नोलॉजी इंपॉर्टेंट होने जा रही है। फैक्ट्री में देखिए, फैक्ट्री में भी हम इन सबका यूज क्यों करते हैं कि देखिए एक टाइप की आपकी जो शर्ट बनती है सबका एक साइज होता है, कोई उसमें डेविएशन नहीं है। इसका मतलब वहां मशीन में प्रिसीजन है। जो मशीन में प्रिसीजन है किसी प्रोडक्ट में बनाने के लिए, वही प्रिसीजन जब आपके एग्रीकल्चर में होगा तो इनपुट यूज इफिशियंसी बढ़ जाएगी। इनपुट यूज इफिशियंसी बढ़ेगी, इनपुट कॉस्ट कम होगी, रिक्वायर्ड इनपुट का जो रियली रिक्वायर्ड है उसी को आप यूज करेंगे तो कॉस्ट ऑफ कल्टीवेशन कम होगी। जब कॉस्ट ऑफ कल्टीवेशन कम होगी, क्रॉप प्रोडक्टिविटी बढ़ेगी, इसका मतलब जो प्रॉफिट मार्जिन है वो भी इंक्रीज करेगा। तो ये टेक्नोलॉजी का डेली लाइफ में यूज होने जा रहा है। हो सकता है उस समय हम लोग अभी यूज कर पाए, बट आप सब लोग जरूर इसका यूज करेंगे।
जैसा कि आपने सर बिल्कुल सही कहा, जैसे सेंसर हुआ, ऑटोमेशन हुए, टेलीमेटिक्स हुए, ब्लॉकचेन हुए, इनके अलग अलग स्पीकर्स हैं जो इनके स्पेशलाइजेशन की बात करेंगे।
बिल्कुल वो बात करेंगे, डीप में बात करेंगे।
सर एक लास्ट क्वेश्चन सर पूछ रहे हैं कि व्हाट विल बी द फ्यूचर रिपरकशंस इफ वी आर यूजिंग सच टाइप ऑफ टेक्नोलॉजीज।
ओके, वेरी गुड। आज के 20 साल पहले हम लोग सारे लोग जो इतिहास पढ़ते हैं, अगर नहीं उस समय याद है जब कंप्यूटर का टाइम आया अपने यहाँ इंडिया में 90 से कंप्यूटर स्टार्ट हुए। 1990 से पहले कंप्यूटर यूनिवर्सिटी में एक या दो होते थे, मेन फ्रेम कंप्यूटर होते थे 80s में। जब 90s में कंप्यूटर आए, डेस्कटॉप कंप्यूटर, उस समय एक आ गया कि अब सब कुछ काम कंप्यूटर कर देगा तो इंसान क्या करेगा, जो मेन पावर है वो क्या काम करेगी। आज देखिए कंप्यूटर हर एक की टेबल पे है, अगर टेबल पे नहीं है तो मोबाइल में है। क्या कोई बेरोजगार हुआ कंप्यूटर की वजह से? नहीं हुआ, इफिशियंसी बढ़ गई सबकी। तो जो टेक्नोलॉजी कोई भी आती है उसका पॉजिटिव और निगेटिव दोनों होता है। जब ये टेक्नोलॉजी अगर प्रिसीजन एग्रीकल्चर की आ रही है तो स्वाभाविक रूप से प्रोडक्टिविटी बढ़ेगी। जब प्रोडक्टिविटी बढ़ेगी, प्रोडक्शन बढ़ रहा है, बढ़ेगा, इसका मतलब अब जरूरत कहाँ पड़ेगी, अब हमें प्रोसेसिंग में जरूरत पड़ेगी। तो जो मैन पावर जिसकी आप बात कर रहे हैं ये प्रोसेसिंग में जाएगा। अभी हमारा जो फूड वेस्ट होता है इस फूड की रिसाइकलिंग में जाएगा। तो मैन पावर का कभी रिक्वायरमेंट कम नहीं होगा इन टेक्नोलॉजीज की वजह से। मोबाइल आया, सारे लोग मोबाइल यूज करना स्टार्ट कर दिए, तो क्या आना जाना कम हो गया, ट्रेवल ज्यादा हो गया। मुझे लगता है कि जब से मोबाइल्स आए हैं तब से बाई रोड ट्रेवल अगर आप देखिए तो कम हुआ, नहीं हुआ। अदरवाइज क्या था कि मोबाइल आएगा तो जाने की जरूरत नहीं है, मोबाइल पर बात कर लेंगे, वीडियो कॉन्फ्रेंसिंग के बाद नहीं जाएंगे। तो कहीं आपने सेव किया है, जो मनी आपने सेव किया है वो मनी आपने कहीं और इन्वेस्ट किया है। अब देखिए टेक्नोलॉजी का यूज करके कितना बढ़िया जो ट्रेनिंग हो रही है। क्या ये संभव था कि 323 ट्रेनिंग्स को एक साथ बैठा के आप ट्रेनिंग देते? अगर किसी लेक्चर थिएटर में 323 डेलीगेट्स बैठे हैं या ट्रेनिंग्स बैठे हैं, 1-to-1 इंटरेक्शन हो रहा हो, ऐसा पॉसिबल नहीं। इंडिविजुअल पूरा लेक्चर सुन पाएगा, ऐसा पॉसिबल ही नहीं है। बट इस टेक्नोलॉजी से दोज हु हैव इंटरेस्ट, कि जो 6:30 से 7:30 तक यहाँ बैठे हुए हैं, इसका मतलब इंडिविजुअल अपने कंप्यूटर पे, अपने डेस्कटॉप पे, अपने लैपटॉप पे या अपने मोबाइल पे कम से कम इस लेक्चर को सुन रहा है। ये क्यों संभव हुआ? ये टेक्नोलॉजी से संभव हुआ। तो कोई भी टेक्नोलॉजी खराब नहीं है, उसका यूज और मिसयूज हो सकता है। अगर हम मोबाइल पे दिन भर व्हाट्सएप चलाएंगे तब तो मिसयूज है, लेकिन अगर ये हम लेक्चर भी सुन रहे हैं तो उसका भी यूज है। तो मुझे लगता है जो ये टेक्नोलॉजी आ रही है, इस टेक्नोलॉजी का यूज ज्यादा होने वाला है। और अगले 10 साल में आप देखेंगे कि जो एग्रीकल्चर सिनेरियो है वो चेंज हो जाएगा, बिल्कुल चेंज होने वाला है। और ये टेक्नोलॉजी जो है वो बून है। मैंने कहा कि प्रिसीजन एग्रीकल्चर के बारे में एक जो हम हमेशा बात करते हैं कि लेजर लेबलिंग कर दिया, प्रिसीजन एग्रीकल्चर हो गई, इससे हमें बाहर आना पड़ेगा। लेजर लेबलिंग इज नॉट only the technology. There are many ways and means to utilize or to deploy these technologies. That's what I wish to say. तो बिल्कुल निश्चिंत रहिए शर्मा जी,
Thank you.
बहुत बढ़िया होगा, सब यूज करेंगे और देश खुशहाल होगा।
Thank you so much, sir, for clearing all the doubts of our participants. So it was a wonderful session and we are really lucky to have you with us. You have explained very well regarding what precision is, what are the different components, how it would be helpful to all the farmers as well as the farming community. You have explained very well how these technology would be saving resources and increasing the farm income. Being a breeder, you also focus on phenotyping and how you can develop the varieties, and that would be one of the significant part of your research and work experience done so far. So thank you so much, sir, for a very wonderful session. Thank you so much, sir.
Thanks, student.
As every day holds the possibility of a miracle, so keep hoping for the best and keep shining. Thank you so much to all the participants in the audience and to our guest lecturer, Dr. S.K. Chakravarti, sir, for today's wonderful session. Thank you one and all. You
Thank
can
you.
leave right now.
Thanks
you,
to
sir.
Team AgriVision. Thank you.
बहुत बहुत धन्यवाद सर, बहुत बहुत धन्यवाद, शादर प्रणाम सर, बहुत बहुत